Is it audible?
Yes, ma'am, it's audible.
All right. Yes, class. So see, starting with ray optics. So here, basically, you have to understand what has been written. I'll give you time to write it down before we start with the laws of reflection. In ray optics, we are going to study two phenomena. We are going to focus on reflection and we are going to focus on refraction. So basically, yesterday we had started with this point. Many students were not there. Today I'll repeat this, and today we'll begin with this. When a ray of light strikes a particular object, then we call that ray of light as the incident light. Now, whenever the term ray is used, it means from the entire length of the light which is present, we have chosen a portion of it. That's why we are calling it as the ray. So ray of light means you have taken a portion of it. Fine. And then when a ray of light is incident, three processes can occur. First is reflection, and the ray of light is which bounces back is known as reflected ray. So reflection is the phenomena in which when a ray of light strikes an object, it bounces back. Now, by which angle should it bounce back? How, in which plane should it move, right? That all things we'll discuss in the laws of reflection. Second is, it can also happen when the incident ray strikes the object, it is completely absorbed by the object. So that second process is known as absorption. Now the bodies which completely absorb ray of light, we call them as black bodies. And the last one. See, if this incident ray wasn't obstructed with this object, what would have happened? This incident ray of light would have moved straight, right? Now there is a deviation in the path. So this deviation in the path of the ray of light, this is known as refraction, and the ray of light is known as refracted ray. So we have portions from mirror, there we'll study reflections. We have portion from lens, there we'll study refraction. So starting with the laws of reflection, then you people can, those who were not there yesterday, because I just started with this and I hadn't further extended it. So you people can write down this, but first let us discuss the laws of reflection. Now see, class, when we are talking about reflection, this is clear what is meant by reflection: simply bouncing back of light whenever it strikes an opaque object. Because usually whenever it strikes a transparent object, light rays, they get deviated. Fine. Refraction occurs. So best reflection occurs in mirrors whenever you have smooth surfaces. Fine. So what is meant by the first law of reflection? Whenever we use the term laws of reflection, this you people have already done in your class 9th and all. I think 9th, 10th,
10th.
10th, yes, 10th class, this was included, ray optics. Now see, whenever we start, whether it's lens, whether we are talking about mirrors, first thing that you have to do is drop a normal. Normal term by default means that something which is making an angle of 90 degrees. Fine. So angle here that is formed is 90 degree on the surface of the mirror. This is a mirror. This is a plane surface. Let us take the plane surface. Now, how have I taken this plane surface? See, this part is the smooth part through which reflection will occur, through which the reflection will occur. These lines, these small lines which I'm drawing, these are depicting that it has been polished on one side. It has been silvered. So no other phenomena can occur here. So this will make the fact clear that incident ray will be over this side only, not on this side. Fine, that's why we draw like this. So normal is must. Normal is the 90 degree, is a line which is drawn 90 degree at 90 degrees perpendicularly. But whenever we are dropping an incident ray, I told you incident ray will be the ray which is striking first. So a ray of light, this has struck it. So what do we call this? We call this as the incident. This is known as the incident ray. This is the normal. Now, when this ray of light, this bounces back, we call this as the reflected ray. This is known as the reflected ray. All right. Now see, this is one angle that is being formed over here. See, this angle is known as angle of incidence. So what is meant by angle of incidence? This angle of incidence is basically, this is angle of incidence. So what is meant by angle of incidence? You can look at the figure also and answer. It is the angle that is formed between the incident ray and the normal, not the reflected ray. Incident ray and the normal. There can be one confusion when you are answering questions and when we are doing numericals, that this, no, not from the surface of the mirror, not from any other surface. So this is basically when you are taking it directly from between incident ray and the normal. So this is angle between the incident ray, angle formed between the incident ray and the normal. This is known as angle of incidence. And second will be very much similar. This becomes angle of reflection. So this is angle of reflection. So again, what is meant by angle of reflection? The definition of angle of reflection is also not difficult now. It's the angle that is formed between the reflected ray and the normal. It's just that whenever we are practicing numericals, whenever we are solving questions, this becomes confusing sometimes, that we take the reflected angle of reflection from the surface of mirror. So be careful with that. Always you have to drop the normal. If normal is being parallel, then angle will be 0. That is fine, but you can never take it from the surface of mirror. So angle of reflection is what? This is the angle between reflected ray and the normal. Now, this is not any law that we have to define angle of incidence or any other. First ray of light you should be aware is the incident ray, firstly. Second ray that we draw first is the normal, because it is a reference. And see, normal is not actually a ray which is present. Like you are able to see incident light striking, you are able to see the reflected light, you are able to see the image formed by the reflected light, right? But when we are talking about normal is not an actual line which is present, through which you can see and check that yes, normal is being formed. It's a hypothetical concept just for our references, that we are able to take incident ray properly, we are able to take the reflected ray properly, we are able to take all the angles properly, and all the laws are abided. All right, so that's why normal is not an actual ray. But when we are talking about incident ray, whenever we are talking about reflected ray, they are actual rays which are existing. And class, whenever you are depicting a hypothetical ray, try to write it in a dotted manner. Whenever you are writing a complete ray which is actually existing, then only make it in a continuous fashion. That means this ray is actually existing, because you also know an incident ray strikes. So it is actually light which is coming, which is striking. The reflected ray is also a light which gets reflected and is formed. An image is formed. So the first law of reflection basically says that this angle of incidence, that is the angle between the reflected ray, incident ray and the normal, is equal to angle of reflection. That is the angle formed between the reflected ray and the normal. So this is the first law of reflection. Angle of incidence ray is equal to angle of reflection. This is helpful for your numericals also. And this gives you the perfection to draw the mirror images whenever mirror images are drawn, or whenever a ray of light strikes. Second point says that the reflected ray, incident ray, normal, all these three which we have marked, incident ray, second this normal, third this reflected ray, all of these lie in the same plane. This means, see, when I am talking about same plane, we have these three axes, x-axis, y-axis, z-axis. Now in between these axes we have the planes. XY plane is existing over here, YZ plane is existing over here, and over here you have xz plane existing. So this means, see, it cannot happen that at the x axis xy plane, between the xy plane, a ray of light has strike, and then reflection is at the same angle only, but reflection is occurring along the yz plane. No, if this has occurred over here, then exactly after drawing normal, this will go like this. This is what is meant by it. Whenever we are saying no, same plane means these. Either we are talking about xy plane, or we are talking about yz plane, or we are talking about zx plane. So you can never make a ray of light incident along the xz axis, along the xz plane, and have the ray of light being passed through the xy plane. Planes have to be the same. So that is the second law of reflection. Either xy plane, everything will occur in the same plane. Normal will also be dropped in the same plane. If a ray of light is incident, suppose here, let's take this example. Ray of light is incident in the xz plane. So normal will also be dropped here only in the xz plane. And the reflected light will also be within this same. Can you see all of these are ultimately lying in the same plane, and the plane is xz plane. So the reflected ray, the incident ray, and the normal all lie in the same plane. This is the second law of reflection. So these are the two laws of reflection which you should remember. Rest of the details we'll discuss regarding mirror. Those students who were not there yesterday, just write down this. And then once this is done, everyone will write the laws of reflection and make the heading as reflection only directly. Your chapter's name is ray optics, but the topic that we have started is reflection. Yes, class. Now starting with mirrors. So as I've told you, in reflection, we'll be focusing on mirrors. When we start with refraction, there we'll see lens because their refraction of light occurs. Now starting with reflection, and that is spherical mirrors. So firstly, what is meant by spherical mirrors? The types of mirror you already know. You people are already aware of concave mirrors and convex mirrors. Now, what are the specialities about these mirrors? Firstly, you have to understand that the mirror that we are actually considering, it's a part from a hollow sphere. This is the hollow sphere. Suppose this is a hollow sphere. If I cut it like this, these dotted lines which you are seeing, if I cut it like this and then I take this curved portion, that will be a mirror. Understood? Mirrors that we see, the spherical mirrors. When we are talking about mirrors over here, this means spherical mirrors. Plane mirror is different. That is not a part of these spheres, right? We are focusing right now only on spherical mirrors. So suppose if I take this and I have painted this outside like this, I have silvered and painted, silvered it or polished it from this outside. So only this inside portion is available to me, right? I have cut it. So what will I obtain? If I take this curved part, this was the entire circle. I have cut it from here like this. And this part, this I have silvered it. I have painted it, I have silvered it so that no reflection occurs. So which area is available only for reflection? This area, right? So these types of mirrors, we call them as concave mirrors. Bulged outer part is silvered. This is why concave mirror, because you obtain a concavity where reflection and any other phenomena of light can occur. So these mirrors are called concave mirrors. Fine. So reflection will occur from the inner hollow portion and outer part has been silvered so that no reflection can occur. If again I have this entire circle with me, entire sphere of hollow mirror with me, and I have again cut it. Now this time what I'm doing, instead of silvering it from outside, I have painted it from inside. I have polished this surface from inside. So now no reflection will occur from this side. So I have this area only available for reflection. That is, the bulged part is only available for reflection to occur, for the incident light to strike. So such types of mirror we call as the convex mirror. Inside, whenever you see some hollow part, concavity is present. So concave mirror, bulged outer part, that is convex mirror. That is only written over here. So bulge is silvered, reflection from inner hollow surface. Reflection occurs from bulged surface and is new, and inner is polished. So inner part is polished. Now, see, someone asking.
They are a part of a sphere.
Yes, they are actually part of spheres. See, when we are because sometimes entire spheric sphere is also used, but see, when you are taking the entire sphere, you are not able to concentrate the light at a point. That's why we take a part of the mirror. And now see, whenever we are taking, this is what I was going to explain the next, that whenever we have the mirror, you must have heard of these terms, radius of curvature, pole, and all. These are very basic terms which in class 10th also you people have studied. So what actually are these terms? We have taken a portion of mirror, we have silvered it for our convenience, for the reflection to occur. We have done these modifications, right? But in reality, this was a part of an original sphere, right? Which was hollow original sphere. So whenever we talk about a mirror, we talk with the reference of this hollow sphere only. For example, see, this was the hollow sphere which I'm talking about, of which a part of the mirror was taken. So there will be a center of this. Center of a circle exists, center of a sphere exists. So here also center of a sphere will exist. So what do we call this center as? Center of curvature. So the actual center of curvature which you use in the exam, you draw a mirror, you write the C, you mark it as C, F, R. So this is the center of curvature. This is the center of curvature. Fine. Now, this portion, just first look at this axis. This is a line that is drawn across the diameter of the sphere. This is called the principal axis. This is a very important line for our references, for the light rays to strike and the images to form. So this is known as the principal axis. This is known as the principal axis. Now see, there is a point at which this sphere crosses with the principal axis. So this point we call it as the pole of the mirror. This is known as pole of the mirror. And pole is a very important reference point because all the striking and all the passing of rays occur from pole. And why? Because you can see this is actually the point at which the principal axis, this line that is drawn parallel, is crossing with this sphere, hollow sphere. Fine. Then see, one more thing. This is a sphere. For every circle, whenever we talk about circles, whenever we talk about spheres, there is a radius which is same in all directions. So here also, this entire portion, this is the radius of this sphere. So we call this as the radius of curvature. Radius of this entire curvature. So this becomes radius of curvature. Now see, whenever we have taken a portion of the mirror, there is a point at which all the rays will ultimately converge. All the rays will intersect and meet from wherever direction they are coming. All the incident ray will converge at a point. That is known as the focus. And the length is always taken with reference to pole of the mirror. I have told you pole is the reference point. So this becomes the focal length. And this point is what? At which all the rays are coinciding. We call this as the focus. Fine. Okay, now let us name this as something. This curved part of which we have cut from the mirror. Even we cut it, center of curvature will remain there only to its or at its original position. Radius of curvature will be always taken of the hollow sphere to which the smaller sphere was a part of. Fine. Now let me name this as something. Let's say this is A, this is the pole P is already there, this is some B. Look here. This curved part, no, this if you see this curved part to which is open outside. When we'll cut it, this was the sphere. Suppose this is A point, here is P, and this is B. So when we'll cut it, this will be APB. This part, this is known as the angular aperture. This curved part which you are seeing, this part, this is known as the aperture. So I'll write it down here. APB. This is known as the angular aperture. Angular aperture. And when I'm just talking about this part, just this, not the curved part, not this curved part, just this part. See, only this part when I'm talking. A point, B point. See, this entire was the curve. A point, B point, just this. This is known as the linear aperture. So APB is the angular aperture, AB is the linear aperture. So center of curvature, radius of curvature, focus, pole, principal axis, apertures of the mirror. These are enough, I think, right now. These are all the points of landmarks that we use whenever we are drawing ray diagrams. So if anything else is there, I'll mention it. But these are the basic points which you should know. Because we'll be now we'll not be discussing this in detail. We'll be just drawing a curve, a center of curvature, focus, radius of curvature, and everything by ourselves. So you should know that center of curvature which we are marking is actually the center of a circle, center of a sphere. The radius of curvature is actually the radius. All right. Write down the headings, spherical mirrors. Write down all these points. See, Fadil, focus is a point where all the rays of light converge at a point. So whenever incident ray is striking, see, like this. Whenever, if we are talking about a convex surface, suppose. So on a convex surface, these are the portions that will be striking, right? The outer part. So at a point, the final image where it will be formed, that is known as the focus. So for convex and concave, the focus shifts, it is different. We'll see for separately for every mirror. And suppose it is coming from this side only for a concave one, then also it will strike at a point after getting reflected. So the point at which the image is formed is known as the focus. All right. So now focus, everything we measure with respect to pole, I told you pole is taken as the reference point for calculation of images. So from the pole to this focus, the length is known as the focal length. Clear? Now for using all these mirrors and spheres and everything, there is a proper sign convention which has to be followed. See, when we are talking about new Cartesian sign convention. Yes, Fadil, clear?
Ma'am, yes, ma'am, clear. Can you show the last slide once again, ma'am? Just 1 second.
Yes, yes.
Ma'am, the previous one. Yeah, done, ma'am. Thank you.
All right. Now, see, let's start with the sign convention. So see, when we are talking about the new Cartesian sign convention, some rules are there. First is that wherever you are drawing or wherever you are taking the sign convention, that is taken along with the ray of incident ray of light. So we take the direction of incident ray to be positive. Suppose the incident ray this is the direction of incident ray. So direction of incident ray is taken positive. Or you can say light rays which are moving towards the mirror. But it's a method to remember. Actual definition is that all the rays which are moving along incident ray, these quantities we take as positive, and all the things which are in opposite to the direction of incident ray, we take it as negative. But a better way and which gets easier to remember is that if you remember it like this, anything which is kept behind the mirror, here, behind the mirror, will be considered positive, because see, that will be along the incident ray. And anything which is kept here, how will that be also be positive? You will always take pole as the reference and then move towards the point. Suppose I take something over here, one object. So from the pole, if I'll move, it will be in the direction of incident ray. If I put something over here in front of the mirror, now from the pole, I am moving towards this. From the pole, I am moving. So can you see it's in opposite direction, right? This is in the...
Ma'am, can you repeat again?
Yes, yeah, see.
Ma'am,
We have
actually,
to
I
take...
was from starting.
Yes, Chavez?
I had to go somewhere, so can you repeat from starting like this new sign convention?
Cartesian system, I'll repeat. See, first method is that anything which is kept behind the mirror, that is taken as positive, and anything this which is kept in front of the mirror, we take them as negative. Now, reason is that whenever we see any object or whenever we do the measurements for mirror, I told you we have to choose pole as the reference point. So if I'm putting something over here, from the pole, I will go in this direction and measure. If I'm putting something here, from the pole, I will go and measure in this direction. If something is kept here, again from the pole I will measure. If something is kept here, from the pole I will measure. This is how the light rays have to be measured. From the pole you have to move. If it is kept in front of the mirror, so you will move like this. If it is kept behind the mirror, you will move like this. Fine. Now regarding this...
Yes, ma'am, understood. But why did you write incident ray as positive?
That I'm telling. So this is how we take from the pole you move, you take that as the distance whenever you are performing the calculations. Also, if you have kept an object and you are calculating, so from where will you calculate? If I have kept an object over here, which distance should I take? So again, reference is pole. Start moving from the pole, this much distance will be taken. Even if another object is kept here or any other thing is kept, no, you take it from the pole. This is a reference. Now coming to the point when I mentioned that incident ray is taken positive. See, the direction of incident ray is taken positive for every quantity. Whenever even we, you people have done this concept of relative velocity also in class 11th. So there also you must have seen we take the particular direction. So direction of incident ray is taken positive. Suppose light rays are moving like this. This is the direction of incident ray. So this tells you that from left to right is positive. This is depicting what? That left to right is positive, right? So suppose I have kept an object over here behind the mirror. How will you move? Whether it is it left to right or right to left? Obviously, you are moving from the pole. So the direction is this. Can you see? This is the exact same direction of the incident ray. So whichever quantities are coming like this, you will take them as positive. Suppose object is kept, object separation from the pole, we call this as object distance. So if the object is kept here behind the mirror, you are moving from the pole towards the object. So how will you move? This is the direction. You will not move like this, right? You will always move from the pole to the object. So this separation, which is the object distance, this is in the direction of incident ray. Because obviously, if this is the mirror, incident ray will strike like this. Incident ray will not strike from behind, right? So it means this direction will be then positive. Take the same example. I have kept an object over here. How will I calculate? The incident ray will be falling on the mirror like this. Now from the pole, I'll be moving. If from the pole, I am moving like this. So which direction is this? This is this direction. Exactly opposite to the incident ray, negative. Here this was positive. We were moving along the direction of incident ray, left to right. Here this is becoming right to left, opposite. This will be negative because this is opposite to the direction of incident ray. In short, what did I tell you? Anything that is kept behind the mirror is positive. Anything kept in front of the mirror, that becomes negative. So this time, this separation, this object distance, this will be minus u, not you. If this we take this becomes you. Now tell me, is this incident ray concept clear to all of you?
Yes, ma'am.
Is incident ray, direction from the incident ray is always taken positive. And direct rays, all the rays which are moving in opposite direction are always taken as negative. So even if I draw an object over here, I am taking object distance. Suppose, for example, this object distance will be negative over here because this is an opposite direction. Even if you reverse the mirror, suppose I have taken this part of the mirror. Now something is kept in front of it. Move from the pole. What will be now the direction of incident ray? Incident ray's direction will be this. So now for this mirror, right to left will be positive. Take this. From the pole you are moving and calculating the object distance. So this is the direction from the pole towards the object. This will be minus u this time. All right. So anything, that's why I'm saying anything kept in front of the mirror negative, behind positive. That is applicable anywhere. But you should just not remember it like that. You should know the logic why we are remembering it in that order. Because ultimately it becomes an opposite direction of incident ray. So anything that is kept in front will be negative.
Ma'am, is it based on the concept of number line? Like after this,
No, not concept of number line. Number
only behind the mirror and front of the mirror. Only that.
No. See, this is nothing like that which you're saying. Like 0 is the reference line and these are positive numbers and negative numbers. No, this is a sign convention. Sign convention, like you take left side positive, you take right side negative, like this. So whenever we talk about relative velocities or whenever two vectors are in opposite direction, what do? We take one as positive by ourselves, we take other as negative. That is the sign convention. In mirrors, in ray optics, there's a specific sign convention kept. You cannot choose one side of mirror as positive, one side of mirror as negative. So as to specify that, we have this concept along incident ray and opposite to incident ray, because incident ray striking at a particular mirror will be universal. Whenever we choose sign conventions, you take the concept of relative velocity, or you take the concept of motion under gravity. If a ball is falling downwards, or suppose, let's take, I have thrown a ball upwards. So displacement is occurring upwards, velocity is upwards, gravitational, the acceleration due to gravity will be downwards. So it's upon me if I choose upwards as positive and downwards as positive, right? That depends upon me. So whatever will be my final answer will be defining the direction. That's how we usually do. But this liberty is not there in ray optics. This is already given to you. Anything kept behind the mirror, so positive. Reason? Because that is along the incident ray. The actual sign convention is along the incident ray. This is not a sign convention kept behind on front. That is what I am telling you to remember. So along incident ray is the sign convention which is being assigned. Now you inverse the mirror, you reverse the mirror, you take this curved mirror, anywhere incident ray will be striking, and that direction for that particular mirror will be taken as positive. So like this, these rules are specified. One more thing, whenever we are talking about height of mirror, these are specifically for object distance and image distance, which we discussed. When we are talking about height, see, suppose this is an object. Anything which is kept above the mirror, above the principal axis, this is our principal axis, that is taken positive. Height of image, height of object we'll be using, so that is positive. And something which is below, object is obviously never kept below the principal axis, so object's height will always be positive, but images can be negative. Images can be drawn behind the principal axis because images are formed wherever light rays intersect. So if something is formed below the principal axis, this is taken negative. This is how you have to remember the sign conventions. So all ray diagrams are drawn with the incident light traveling from left to right. Fine, left to right. Left to right basically means if you inverse the mirror, that becomes right to left, whichever type of mirror you have taken. All distances are measured from the pole. This also I've told you. All distances measured in the direction of incident ray is positive. All the directions measured in opposite to the direction of incident ray are negative. Heights measured above the principal axis, heights are measured upwards and perpendicular to the principal axis positive. Heights measured downwards and perpendicular to principal axis negative. So these are the sign conventions which I have discussed. Write it down now. Still also, if you people are getting confused with any sign convention, let me know the point. But draw this first, then write down all the points. Fine, all those who have completed, see, now we have to start with the ray diagram. So ray diagram freshly I'll start in the next class because this won't be completed today. Fine, now all those who are having their classes, half an hour break is there for you. And others you can leave. Please revise the sign convention. These are all the basics of ray optics which we discussed.